with the what looks like a sort of green green screen here. So I will stay away from anything relevant to color, which was my plan anyway. And then next class I will bring a different adapter. So again, for those of you watching from the videos, I'm having a small technical issue with my display adapter that I don't seem able to fix. So we're going to have to just run with it. So I'll get that music down. Hello and welcome to 107. Again, if you're watching this video maybe after the fact, you may find that it has a slightly green cast to it, like it was maybe in the Matrix or, I don't know, hit with some spell. Looks fine for us on the projector, so that's kind of nice. In any case, we're going to go ahead and kind of continue on with P5 today. So we're spending pretty much the entire class period of this week, next week, and the week after, thinking through and working through issues related to P5. So does anybody have any questions sort of before we begin? Anybody? Anybody? Okay, well, then let's go ahead and get started. So if you check the sort of agenda for today, obviously I'll be posting the video, which, oh man, it's so green. It's like lime green. Sorry about that, y'all. So I'll be posting the video later today, later this afternoon, and you may notice that I have a few sort of like PowerPoint or slide style documents. There's Intro to Coding in the Arts, P5, Part 1. Then there's Part 2 and Part 3. And then from there, we kind of move on to more sort of experimental and kind of topical stuff. This Part 1, Part 2, Part 3 is really kind of a, if I were to sit down and write exhaustively, like a guide on how to code or how to use P5. So I'm not going to be delivering them like lectures in the class because they're really more intended as documents. They're intended to provide you with sort of supplemental narrative. So if there's something that we talk about in class that you don't understand, I would absolutely look back at these slides, and they should kind of fill in some of the gaps. Because in class, we're going to spend class time really sort of like doing it, like actually working with the code, because I think that's actually the best way to learn. But I know that we have different types of sort of learning styles in the class, and obviously want to, be accommodating to that. So I think if you are one of those people who learns better by just reading a document, then by all means, have a document. So some of this is stuff that we kind of started to talk about yesterday, like what are some of the basic rules of P5.js? And then we can kind of go on from there. So that idea of the basic rules, and I will refer to these in class, but I'm not going to sort of like just go through, every slide. I might go back and forth and such. So for those of you that are just getting here, I was mentioning that there are 3 PowerPoints on code in the Canvas modules, and they contain lots and lots of valuable information that may help you understand how P5 works. And most importantly for you, perhaps, they will also potentially be on the final exam. I know. So I will probably pull at least 3 or 4 questions out of the final exam into these. So so we are sort of, we talked about some of these things yesterday. So I'm going to start kind of going back and forth. So I'm going to open up a P5 editor. As I mentioned, I believe in class, last class, I mentioned that you can use other text editors for P5. So if you think that might suit you better, go for it. If you're sort of like coming from a perspective where you're completely new to code and code tools, I would stick with the P5 editor. So we sort of get a couple of things. I'm already signed in, so pretty much I think when you're using the P5 editor, if you could just remember to sign in when you get started, it will save you from the classic problem of making this really awesome sketch, not being signed in, and then having to sign in, and having the sign in go badly, and then not being able to hit the back button to go back to your sketch, and having it disappear. You don't want that to happen to you. So when you open up the P5 editor, just double check that you're signed in. I mean, obviously sign in can usually go fine, but I have sometimes one can only remember, so many passwords, or sometimes Chrome doesn't, automatically generate or remember them, and, stuff happens. So when you open the P5 editor, you have these two functions, and we started to kind of go over some of this stuff last class. You have a comment, so a comment is here. And we also kind of noted a couple of things that were sort of rules for P5. We have the sort of universal rule of matchy-matchiness, which means that in general, with coding, any language, if there's an opening character, like a bracket or a parentheses, or really like a square bracket, it probably needs a closing bracket. That's a safe assumption. So in this case, here we're using the curly brackets to kind of wrap around. Obviously, in this case, here's the open parentheses. We also need a corresponding closing parentheses. One thing I didn't remark on in class is that, last class, is that there's some debate over whether you need a semicolon at the end of a line. The P5 web editor will actually function just fine if you don't use the semicolon. I sort of think like that's bad training because many other related computer languages, particularly JavaScript, in certain situations you do need the statement end line there. So the fact that it's not asking for that semicolon is really just particular to this editing environment. And so my advice would be to just use the darn semicolon because it's kind of like a way of future-proofing and also making your work a little bit more portable and kind of compatible with other editors. So I personally will use the semicolon. So if that confuses you, I'm sorry. It's not intended to. To make it not confusing, we could just kind of all make a pact to use the semicolon. Okay, so that semicolon basically lets the editor know that this, which is a function call, that this is basically done. That's what the semicolon is telling it. And so that if we put a new line here, it will be able to kind of parse that. So I remember drawing an ellipse last class. That's usually a good thing here. And I remember also, just as like a general sort of, I'm maybe coming from a beginning perspective, get that semicolon on there. And I can also sort of write myself a comment that sort of encapsulates the way that the function works, or what sort of input that command or function wants. You may be asking yourself, hey Meg, that's great that you know that, but what if I don't know that? Where do I find it? That's a really super good question. So the way that you would find it is you would go to the P5 reference. And computer languages are sort of, not really, you don't learn a computer language the way you would learn a natural language, like the way you would learn French or German. Most people learn computer languages by actually solving problems and by navigating through tasks that they need to do. And so it tends to be sort of something where you're actually, looking for something. So within this reference, this is a super comprehensive, super searchable reference for every function that's part of the P5 language, okay? So literally anything that you would want to do in P5 or any that's actually part of P5, you would find in this list. And it's organized by topic, but you can also, it's also very nicely searchable. So it does just so happen that there's a whole category for shape primitives, and then it has an entry for all the different kinds of shapes that you can make. Let's click ellipse and see what that reference page looks like. So usually, and the nice thing about the way the reference is laid out is that it sort of has the exact same format for every function. So in this case, the ellipse function, it gives you an example of how it would be used in code. And then it gives you a description, which here is pretty obvious. Sometimes there are certainly functions that are less obvious, like draws an ellipse to the screen. Oh, thank you. I think we probably assumed that, right? But it also sort of gives us some additional input about what happens with the different, I would call these inputs, like that the first two parameters set the location of the center of the ellipse. So each of these would be a parameter. And the third and fourth set the shape's width and height. If no height is specified, then it just uses the width as width and height and makes it the same. So there's a lot of functions in P5 that don't have, this is actually one of the simpler functions in terms of the parameters that it accepts. So here it's sort of like, yeah, I accept coordinates and I accept a width and a height. If we look at something like the background function, it has maybe like 15 different ways of inputting parameters, and it will just give you a bunch of examples. So we'll look at that. And then it sort of unpacks like, okay, the parameters are here. So the x coordinate of the ellipse, gets plugged in here. So it's basically just kind of unpacking these abbreviations through this log of parameters. And so let's maybe put some of this into practice. So it looks like here we have width and height. So right now it's set to be 300 pixels wide. By the way, the default unit in P5 is pixels. So based on what that reference page said, if I take out this fourth parameter, it should assume that 300 is going to stand in for width and height. And indeed it did. We got something kind of uniform, right? So I'm going to make this a tiny bit smaller just now. And I think I'm going to make the screen a little bit bigger. So we're using the create canvas function. There are some areas where you might have an additional parameter here, but we're not going to kind of get into that yet. This is sort of just how to create a two-dimensional window. And then later today, we might also kind of take a look at the background. But for now, we're going to really focus on how code flows in an environment like P5. And I think we'll also make a variable. So here, in this case with the ellipse, we have 1 right now. So let's draw another ellipse. Again, I'm cutting and pasting from myself just to kind of make my life a little easier. Okay, that's brilliant. Now I have 2 ellipses that are drawing at exactly the same location. Was being slightly sarcastic when I said that was brilliant. Yeah, it's like we're not sort of appreciating that second ellipse because it's getting drawn, oh Lord, right underneath, hang on. Oh my gosh. So what we're going to do is we're going to move those coordinates so we can see both ellipses. And I've created quite a situation for myself here. Sorry. Oh. this happen? I'm almost there. Okay, done. So let's just move these coordinates. So here we have an x and a y. So it's at 100, 100 right now. So let's go ahead and put this one at maybe 200. Well, something kind of important has happened. What has happened is that we have sort of illustrated visually how statements in code are executed. And so let's call this one and this is just for my purposes. So if we had something like ellipse 1 and ellipse 2, why is ellipse 2 drawing on top of ellipse 1 is my question for all of you. Yeah. Yeah, so the objects are drawn to the screen in P5 in the order that they are called by the interpreter. And so the interpreter, this is pretty much, I would say, a sort of general rule about all code languages, although I think sometimes people try to invent ones that don't follow this convention just for fun. Almost every code language that I've ever heard of goes from top to bottom. In terms of the code document and the order in which it is either executed or compiled. So that means that if we continue to draw ellipses here, we can certainly, build up like a stack. Let's push this down 100 pixels, 100 pixels again, and we get this nice little stack. Let's try doing some of this stuff a tiny bit differently. Let's go ahead and take this last one in the stack, and I'm going to make one here and put it at like 500 and just see what happens. And so you can see that this one, despite the fact that it's numerically more than the other 4, because it's executed first, it gets pushed behind the others. Yes? Yes. Yes is the answer to that question. So yeah, basically this is equal to this. It's exactly the same. So I'm just being lazy. I'm a huge fan of being lazy, especially when it comes to code. Leads to slightly more efficient code. So let's go ahead and kind of think about other ways that we could maybe do something like this, because I would say if you were looking at this from a code perspective, this is perfectly fine from a visual perspective. It looks, it's displaying on the screen, it's doing what it's supposed to do. But it's also sort of like, I don't know, I'm not really great with colloquial terms, but trying to think of a good word for it. Like, it's a little kludgy, it's a little, definitely the sort of technical code term would be that it's very inefficient. And why is it inefficient? Because you're sort of enumerating or you're sort of defining ellipses that are extremely similar over and over again, right? And in general, with code, you can certainly develop things by just entering in numerical values, but it's usually better if you can attach some kind of a variable or an expression to that. To build efficiencies. So let's talk about variables. I'm going to make another stack of these ellipses, and we're going to use a variable. So I'm just going to go with the 1 through 4 stack here. And I'm going to create a variable. For the purposes of your sketches, in general, I think what are called global variables will serve you best. There are certain situations when we have to use what are called local variables. And we'll get into that as we kind of move forward with coding. But for now, I think probably global variables are going to be best for us. So a global variable is called a global variable because it's basically going to be able to be used throughout the entire body of your code document. A local variable is called local. It's like you're on the local train. You can only go to certain local stops within a defined area of your code. So a variable is really just like a variable back in math class, maybe algebra, where you're setting in this case, a variable that's called x, and we're setting the value to 100. So here, I could go ahead and sub x in for this, and basically nothing will change. I probably think that if I'm going to use it for the x coordinate, I probably should go ahead and add some pixels to it so that it moves over to the side, because the other stack was drawn at x 100. So if we draw this stack at x 300, that might be kind of better. So I'm just going to go ahead and replace x for everywhere where it says 100. Now, there's a certain amount of like work and mental sort of mental thinking that's involved in kind of setting up a variable. But once we get it done, you hopefully will understand why it's so awesome. So here, we're sort of out of instances of 100 or 300. So probably I would actually have this one be, let's make this one y. I'll set up another variable called y. And I'm going to make that 100. And here, this was 100, so that's just regularly y. This would be y times 2. So I can actually enter an expression in here. And then this is y times 3. One thing that I also really like to do when I'm sort of starting to actually do stuff is I like to run it very frequently, mostly just to make sure that you're not making huge mistakes along the way. Ideally, you would want to run it or hit the play button like every time you make a change, because otherwise, if you make like 15 or 20 changes and then you hit the run button and it doesn't work, you're like, oh my God, what did I do? And there's really no way to sort of like, you have to start backtracking then, and that's just super annoying. So also, same here on the scale, I'm going to go ahead and fill in for these y times 2. So, and I'm going to make sure that they display. So, okay, I mean, I've got 2 stacks that are now identical. They're identical, but they're not, right? They're just enumerated or sort of called in a different way. Now, where do I get the benefit of using something like a variable? Well, that's a good question. I would say probably the benefit comes when you want to make changes. So let's say I wanted to change the way that this is registered across the screen here. So I could take the x coordinate and just change it to 400, and everything will change instead of me having to make like, probably a couple dozen key presses to adjust that number, right, in each little place where it's enumerated. The other thing you can do is you could consider maybe getting into adding a little bit of motion. So here I could take y, and this is a shortcut operator that adds 1 to y every time the loop completes. So you may be asking, what's the loop? What the heck are you talking about? Well, you don't know this yet because we haven't really maybe explored it, but processing, or P5, when we draw to this window, we're drawing to that window at a rate, and it actually is refreshing at a certain rate. So let's go ahead and see what this does. Right, so now every time it loops, we're adding 1. Now, obviously, we may need to do more than this in the future. Like if we wanted it to go back and forth, we'd have to add in some code. We're going to get to that on Tuesday. That would be conditionals and iteration. So, because this will literally go on forever. So if we take one of our lessons from last class and maybe use the print line function to print the value of y, you'll be able to see real clearly that y is iterating off into infinity. So just full disclosure, every once in a while I'll make very small mistakes, and that's because I work in like 3 or 4 different programming languages. And they're extremely similar. So, yeah. So you can see this number is just climbing to the sky, and it will keep climbing as long as we're running the program. Now, a question that I get a lot of times from students would be something like, can I make it run slower? Yes, you can make it run slower. You can use the frame rate function. And let's make it run really slow. Let's turn the frame rate down to 4. And so you'll see now that it's moving considerably slower. What it's also doing is it's exhibiting some of the characteristics of a low frame rate, which is a certain sense of like jitteriness or kind of jerkiness, right? Another common sort of question that I get about frame rate, let's go ahead and turn that off, and then the question might be, oh, well, what is my frame rate? That's a great question. What is your frame rate? Let's find out. Let's print the frame rate to the console. In general, your frame rate is going to be as fast as your browser will allow it. Your browser and your computer will allow it to go. And so in this case, it looks like it's not even giving us a value. Let me try the parentheses in there. Yeah. So this is, for web animation, this is a pretty fast frame rate, although it's not like, I wouldn't play Call of Duty with it, maybe. But that's probably about what you would expect. In general, I have heard legend that Chrome will attempt to actually cap the frame rate at 60 frames a second, which should be sufficient for anybody. Sometimes you might get a situation where you're sort of thinking about not wanting the frame rate to go too fast, but you want it to stay at a certain level. So probably a healthy sort of generic frame rate to choose would be 30. But if you don't choose a frame rate, and now you can see we're at 30 frames a second on average. If you don't choose a frame rate, it'll just default to running quickly. So those are certainly some reasons you would want to use the frame rate aspect of things. This method, by the way, of printing the frame rate, it's good for troubleshooting. If you have a program that you're working really hard on and it's just kind of like doing this, use that print of the frame rate, and then you can make changes to the code and maybe see the frame rate pick up a little bit. So you can use that as a way to kind of like debug your code, and it actually works pretty well. So those are just some sort of like very basic techniques on kind of how to deal with P5. I think that let me fill in the blanks here. In general, also, when starting today, when I do these code examples in class, I will certainly post them afterwards onto Canvas. So a couple of other things. Let's think about maybe jumping slightly forward, since we got a little bit of a head start on Tuesday. I am going to do one quick thing, and what I'm going to do is I think I'm going to bail us out of this sort of infinite growth. So before we do that, I do want to kind of just point out to you that this y++, basically any variable with plus plus or either minus minus is known as the decrement and increment operator. It's a really common sort of shortcut operator, and it's super, super useful. I would say it's like probably one of the most useful things that you could do in P5. Because when you're dealing with numbers, being able to iteratively take one away obviously is really important. There are other ways that you could potentially deal with that. The other operator that works somewhat similarly is the plus equals operator. So these two statements are exactly the same. They're just a slightly different style, or a slightly different way of enumerating what's happening. The nice thing with the plus equals operator is that you could do it in larger increments. So if you wanted to say y plus equals, I don't know, maybe 100. I'm going to go ahead and comment this one out. You just see, it's like, right? Because we're adding those numbers much, much faster, right? So maybe even with just 10, we would notice a huge change, right? So it's significantly faster when we add more numbers with each iteration. Now, thinking about how to sort of like bail ourselves out of this sort of situation that we've created where we're just adding into infinity, we're going to sort of like spend our last 10 minutes doing a simple if statement. And what we need here in this situation is we need logic, and we need some sort of limiter. So when the number of y, and I think I'm going to go back to printing y right now, because that's useful information for us. So when y gets to a certain level, we want to basically change the value of y. So probably, I think one of the easiest things to do, I kind of stopped it when it got to the point that it almost filled the screen. And you can see that the value of y at that moment was somewhere around 500, 525, maybe, doesn't have to be exact. But it's somewhere around 500. So we could say something like, if, and then there's a parentheses, if y equals 500, we want something to happen. So if y equals 500, maybe we could send y back to 0. So let's try y equals 0. Now, I do want to draw your attention to one quick thing here. So you can see this is like the sort of like most simple way to get it to loop. We're just sending it back to 0. Could we have it reverse and go in the other direction? Yes, but we don't have time for that today. We'll do that next class. So what I want to draw your attention to, though, in this sort of sketch is that here we have two different sort of math operators. And one is a math operator, and one is a, equivalence operator. So with almost no sort of exceptions, these operators, plus plus, and then the regular equals sign, even this mathematical operator of multiplication, those are pretty much legit in all situations, except within the parentheses of an if statement. So within the parentheses of an if statement, there's a sort of special set, and they're in the PowerPoint, kind of all enumerated for you. There's a special set of operators that are only allowed to be inside of if statements. And so one of those operators happens to be the double equal sign, which, if you're keeping track, that's called the equivalence operator. Whereas this, so this double equal sign is really testing to see if y is equivalent to 500, whereas this equal sign is actually, it's called the assignment operator, and it's actually assigning the value of 0 to y. So the single equal sign actually does something, and the double equal sign sort of just, is sort of stepping back to say, hey, are these two things the same, yes or no? So that's a super important distinction that, you have to know. So, okay, so we've got, 6 minutes. So we've got this y adding thing. We could probably maybe even mix it up a little bit more. Let's change, let's add one more variable. So I'm going to add a variable called direction. And I'm going to give it a value of 1. Now, the cool thing about 1, I never used to like math, by the way, until I discovered coding. It kind of actually changed my life. And the thing about 1 is that if you multiply 1 by -1, what do you get? -1, right? So the number 1 and -1 are a really simple way to toggle something back and forth in code. And that's what we're going to do, okay? So basically, we have the direction going at 1, okay? Which is forward motion. I'm going to change this operator here to add direction each time, rather than adding just 1. Now I have the option of maybe it could get -1, or maybe it could get regular +1. So let me think through this for a second. So if y equals to 500, y equals 0, we might actually not need this anymore, so I'm going to comment this out. I think what I'm going to say is something more like, very close to this, but if y equals 500, by the way, if you highlight multiple lines and hit Command / you can comment them all at once. So here, I think I'm going to say, yeah, if y equals 500, then direction equals direction. Well, I'll do it the long way first, and then I'll show you the short way. So direction equals direction times -1. It just so happens that there's actually an abbreviation for this as well. It's basically the same abbreviation as this. It's just with the multiplication operator. So here it would be multiply equals -1. So now this is going to create a situation where it's going to blow up, and then it should shift back when it hits 500. But now we've created a situation where it's shifting back, and it's just going to poke through 0 and go negative, right? And it's just going to iterate into the negative forever. So we just need that's no big deal. We just need another if statement, or in this case, maybe an if-else statement. I think just doing 2 if statements is totally fine and straightforward. So then we could do if y equals 0, then we also need to flip the direction. Derp. Excuse me. Yeah. Okay, so gotta watch it. So hopefully when it comes and passes through 0, it'll flip again. Dink. There it goes. So yeah, this is basically a variation of the sort of classic bouncing ball example. We have just maybe 2 short minutes, and I would maybe point out to you that right now, we're using this for the scale and also for the y-coordinate. There's absolutely no reason why we couldn't involve x or, any other sort of parameter in this, like color or, and we'll start exploring some of those other sort of dimensions of what code can do on Tuesday. So I think that in general, there's a ton of code examples on the web. I was thinking about kind of one of the things that I wanted to do. I'm actually teaching my advanced code class this semester. And so I thought, for those of you that are in sort of like computer science environment, like I will go ahead and share my advanced examples. I have a library of examples for my advanced class. I can share that with you all if it maybe gives you some ideas. I think in general, what we're trying to do is we're trying to create a situation here where people that are sort of coming from humanities or maybe not, STEM backgrounds can have, a really valuable learning experience and sort of come from a perspective of, learning something from the ground up. So if you are a sort of advanced coder, I want you to know that you can feel free to challenge yourself creatively and benefit from our creative expertise in critique. So yeah, I think hopefully you can find something for everyone. So I, in general, am also like really, happy to help, if you get stuck. So just reach out and email me. Yeah, and don't forget, it's going to be 77 degrees on Saturday, so have a fantastic weekend. I can't believe it. Bye, everybody.